Piecewise functions. These are very useful to us when we are trying to model scientific data or do financial analysis. It's very good for when you have data that doesn't exactly fit a straight line or exactly fit into a perfect parabola. So a piecewise function, this is defined by multiple subfunctions where each subfunction applies to only a certain interval of the main domain, and we call that a subdomain. And kind of an example here, you have sort of 1, 2, 3, 4 different subfunctions that are all going on at the same time and connected to form one main function. So let's look at just a quick example here. Here I'm saying graph the following piecewise function, and you notice it's really two separate equations, f of x and g of x. So all I'm going to do here is just really graph both of these. So I'll do this one in purple, the first one, f of x. So let's go ahead and graph negative x plus 3. So this is a line with just regular slope and a y-intercept of 1, 2, 3. All right, and it's a negative x, so it's gonna be going downwards from left to right. So kind of like this. All right, and I'm just gonna graph the whole thing, and then I'll go back and erase the parts that I don't need. For g of x, I'll do that one in blue. So this is just 1/2 x, 1/2 times x. So this is a y-intercept of 0, because there is no y-intercept here. There's no plus any number. And the slope is 1/2. So I'm going up 1 over 2, up 1 over 2. Okay, so these are our two lines. And all we're going to do from here is just erase the parts that we don't need. So the first function, f of x here in purple, this only exists when x is less than or equal to 1. So here's where x is 1. I can erase everything after that. And for the second one in blue, this only exists when x is greater than 1. So I can erase everything smaller than this. All right, and that's really going to be it. My last step here is just to label the edges of the graph would be an arrow. Right here, this is going to be a solid point. This is solid because this is x is less than or equal to. We have that equal to line on the bottom. So the blue graph, g of x, this is x is greater than 1. This is going to be an open bubble. So I'm not coloring that in because there's no line on the bottom there. All right. What about domain and range? So domain here is all real numbers. X can be anything, smaller that way. It can be 1. There is a value for 1, and it can be anything greater than 1. It keeps going on forever in the direction of that arrow. So your domain is x is equal to all real numbers, and I'm going to use the symbol is a capital R with a line through it. That just means all real numbers. For range, so range, let's look at all the y values. We have y's up here, but there's nothing below this line. There's no y's in the negative or 0, nothing there. So y could only be, y had to be greater than 1/2. All right, because that was my first y value here, was kind of at this halfway mark. And then everything above that. And you notice that I didn't say y is greater than or equal to, because this is an open bubble. There's not going to be a line here because this is an open bubble. Let's do one more. All right, so kind of the same problem here. Graph the following piecewise function. Let's do this one in red, f of x. And here I'm going to graph f of x equals x squared. If you remember that parent function, that is a parabola. All right, so I'm going to have something like this. For g of x, I'll do that one in green. So g of x is equal to 6 minus x, or if you want to rewrite that in y equals mx plus b form, this would be y equals negative x plus 6, and that might help you to graph that easier. So that just means the y-intercept is 1, 2, 3, 4, 5, 6, right up there. And then we have a negative slope, negative invisible 1 slope. So you're going down 1 over 1, down 1 over 1. All right, just like that. And from here, again, all we have to do is just erase the parts that we don't need. So the red graph, the red parabola, this only exists when x is less than or equal to 2. So I can erase this, everything where x is greater than 2. And for the second one, g of x here in green, this only exists when x is greater than 2. So I can erase everything before this. All right, and then let's just go back in, fill in our dots. This is x less than or equal to, I've got that line on the bottom of 2, so I'm going to put a full dot there colored in. And for the second one, this is x greater than 2. This is going to be an empty bubble, not coloring that in because there's not a line on the bottom here. All right, so let's do the domain and range now. For x, all the x values, there's a hole here, there's a gap here, but it is filled in by this x equals 2. There's also an arrow going all the way to the left, all the way to the right. So domain, x can be any number, all real numbers. Or let me say this. X equals all real numbers. For the range, kind of the same thing for the range. So we have y is going all the way up to infinity. And then from here going all the way down to negative infinity. So y, also the same thing, y equals all real numbers. So that's pretty much it. Piecewise functions, just really the same thing that we've been doing. It's just kind of like putting 2 or 3 or more functions all into one function, all into one graph. So that's basically it. Graph all the sub-functions and then just erase the parts that are not needed. And that's basically it.